To reiterate, diagrams embody concepts or ideas, like inside and outside and edge and large and many. And Carl showed us multiple examples of diagrams in his talk this morning. And if you go back and listen to the video of his tape, you'll see he talked about diagrams, and he said, the designs are different because they have different diagrams. I collected these diagrams and we combined them. And I kind of knew what he was going to talk about, but I didn't actually set him up to say all that. Ideas can be implemented and manifested in diagrams, and diagrams can generate maps. And you can run this back. You can say, from this map, let's extract the diagram. Let's see what the ideas embedded therein are. And one important role of this is if you want to make a change, you can take your map up to the diagram and plant the diagram in a different terrain, a different site. Now you'll have a different map and a plan, but the same diagram. And it's a one-to-many relationship. There can be many ideas embedded in a diagram. A diagram can generate many maps. A map can embody many diagrams together, as we've seen. In object-oriented terminology, then, that sort of idea that's frankly borrowed from Linnaeus and manifests in modern programming, you could say that diagrams are instantiations of ideas. So ideas are classes in a sense, and diagrams become instances of them. And maps and plans, in turn, are instances of the diagrams. And it's a, I believe, lattice rather than a simple hierarchy, so that indeed a diagram can have multiple ideas and a map can have multiple diagrams. But these are three very different levels of inferential argument and discourse. We talk about the map, so we care whether there's a cliff and an obstruction and a south facing. The idea was very simple. 2 nodes and a line between them. So diagrams support logical analysis and inference as well as spatial. And that's important because we talk about these in slightly different terms interchangeably. And logical analysis is not necessarily visual, whereas spatial analysis of maps often is. And diagrams sit in between here and support both kinds of inference. Well, if the cliff is between these things, then there's a problem. That's a spatial inference. That they are connected is an ideological concept, or even logical. I bow to the diagrams made by Model Builder, but they're a small subset of all the kinds of diagrams that we need to be able to support in this process. Here's an example from the planning literature. This city-river district diagram describes the recurring relationship. It further suggests potential linkages. The same elements of the generic diagram, city center, main street, peripheral rail, etc., are compared in 4 different cities. So the one role of a diagram is to be able to say, what's similar about this situation and that situation, which are very different terrain and topography, but have similar urban functioning or connected kinds of roles. And you could take this diagram and create a map from it, or you could look at a map and derive a diagram from it. But we don't have very good tools for doing that other than the human eye-brain combination. Here's a diagram that I caught in the wild this fall at the GSD. And I didn't have my camera with me, so I had to reconstruct it. You may not know what it is yet. What if I tell you that's a waterway? That's a highway. That's some green stuff, and that's some built stuff. Well, then that diagram can be instantiated, and the differences between the instantiation and the diagram can be noted. And here's a diagram that's a different plan of the same diagram. And the diagram possibly needs yet another diagram that says they don't have to be parallel, and the highway doesn't always have to be between the green and the blue, and they can go under bridges and get intermixed. Those are design concepts that we want to be able to record and move forward with. And so the act of putting down this one is a lot like building a legend. And whether the legend or the diagram comes first, I don't know, but making a legend and making a diagram are exchangeable, interactive parts of the design process in important ways. And there's an instantiation of that with some green stuff and some gray stuff and a highway, and on it goes. Diagrams are subject of active research. My PhD thesis at MIT had diagrams in the title. That was 20 years ago, and in the last decade, here, for example, is the 5th International Conference on Diagrams and Diagrammatic Representation and Inference. The artificial intelligence community is very interested in these things for, I think, exactly the same reasons I've talked about, the interesting, potent inferential role they play in graphical and visual knowledge and intelligence and other domains of argument and representation. So diagrams are distinguished not so much by their graphic style and conventions, although there are many of them, and we teach and promulgate them and sometimes invent and break them, but by their role in design inference. And they're not sketches and they're not maps, but they function halfway in between concepts on the one hand and maps on the other hand, and that's what makes them, in my view, so potent. Whether something is a map or a sketch or a diagram depends a little bit on how it's used, not so much. You can't always tell by looking at it. But I believe they're essential in our geodesign enterprise and that they require their own research agenda and software support. Thank you.